Data distributions. So with data distributions, we're going to be looking a lot with what you've probably seen before. We call this measure of central tendency, working with the mean, median, mode, range, and sometimes you'll see what's called an outlier. So in the notes, I want you to write down the definitions of each of these. I'll just briefly review what they mean. So measure of central tendency describes the center of a set of data. So this includes the mean, median, mode. The mean is the average, so that's the sum. You add up all the numbers and divide by how many there are. The median is finding the middle value. So when you put the numbers in order from numerical order, when you cross off each end to get to the center point, the center value, that's going to be your median. Now when you put your numbers in order from least to greatest, and when you cross off each end and end up with two middle values, you would find the average of those two. So you would add them together and divide by 2 for your median. Your mode is your most occurring number. Now if you have a few numbers that occur more often than others, there could be a few modes. So for instance, if you had the number 20 appear 3 times and the number 9 appear 3 times, and that was the most often those numbers occurred, then you would have, the mode would be 20 and 9. You could sometimes have more than one mode. Now if there are numbers that do not occur more than once, then there's no mode at all. So mode is the most occurring number. The range is the difference between the greatest and least value. So you would take your greatest value, your least value, subtract the 2 to find your range. And your outlier is a value that is different from the other values in the data set. So maybe you have numbers 1, 2, 3, 4, 5, and then a number 30. 30 would be your outlier with the set of data. So we're just going to get into some examples working with mean, median, mode, range. So here they have the weight in pounds of 5 cats, which are 12, 14, 12, 16, and 16. They want us to find the mean, median, mode, and range of the data. So to find the mean, we're going to add them all up. They add to be 70. There are a total of 5 numbers, so 70 divided by 5 is 14. That would be your mean. Your median, we put the numbers in order from least to greatest, cross off each end till you get to the center value, which is 14. Again, if I had 2 values, like if I had 2 14s in the center, this is just an example, what you would do is you would add them together to get 28 divided by 2 to get 14. The mode are the most occurring numbers. So notice your most occurring numbers are 12 and 16. They both occur twice. So you have 2 modes, which are 12 and 16. Your range will subtract. 16 minus 12 is going to give you 4. So those are your answers for that example there. The next example, they want us to identify the outlier given the set of data. So we have 21, 24, 3, 27, 30, and 24. So all the numbers here are within range except for that value 3 right there. I did put the numbers in order here from least to greatest so you can kind of see too how far 3 is from the rest of the values. So we would say the outlier here is going to be 3. The next example, Josh scored 75, 75, 81, 84, and 85 on 5 of his tests. For the questions below, they want you to choose the mean, median, or mode that gives and give its values. So here you're looking at the different types of situations to describe what represents the question the best, mean, median, mode. So first thing we need to do is find the mean, median, mode. Again, mean is the average, so the average is 80. The middle value, the median, is 81. The mode, the most occurring number, is 75. So you first have to find that. Now we can answer the questions. Which measures describes the score Josh received most often? Well, the most often would be the mode. So Josh has 2 scores of 75, and that represents the mode. So that would be your answer. The next question, Which measure should Josh use to convince his parents he is doing well in school? So which score is actually the best that he would want to show his parents? And that would be the median, because that's the highest value. So the median, because the median is greater than either the mean or the mode. The last thing we're going to learn about in this section is box and whisker plots. I'm not sure if you've learned or heard of these before, but what box and whisker plots are is you're given a set of data, you find your lowest value, your highest value, and then you're working with various medians with box and whisker plots. So it says here, box and whisker plots can be used to show how the values of a data set are distributed. You need 5 values to make up a box and whisker plot. That includes the minimum. We have what's called the first quartile, your median, your third quartile, and your maximum value. What your first quartile is the median of your lower half of your data set. So once you put your numbers in order from least to greatest, here I have an example, numbers in order from least to greatest. You find your median, which is your middle number. Here is your 5. Your first quartile would be the median from your lowest to your median. So you would cross off from your lowest to median, starting here, cross off 4, 1, 2, 4, 2, and 3. This 3 here is the median of your lower half of your data, which is your first quartile. Your third quartile is going to be your median of your upper half of the data set. So after finding your median and your highest value, from the median starting to the next value, you cross off each end. And here we have 7 would be the third quartile, the middle value for your upper set of data. Then sometimes with box and whisker plots, they'll ask you for the interquartile range, which is the difference between the third and first quartiles. So what you do is you take your third quartile, here is 7, you subtract your first quartile from your third, so 7 minus 3, okay, 7 minus 3 is 4. Here we have data to make a box and whisker plot. We have here 13, 14, 18, all these numbers, and we want to make a box and whisker plot. So the first thing we need to do is put the numbers in order from least to greatest. So here they are. Make sure you include all the numbers. The next step is we want to find the 5 values, your minimum, your first quartile, your median, your third quartile, and your maximum. So after I put them in order, my minimum is going to be 11. Your maximum is 23. Again, to find your median, you cross off each end. Notice we have 2 middle values, so that's your median, but when you add those 2 middle values together and divide it by 2, you get 14. So we have 14, but now what we need to do is find our first quartile and our third quartile. So from our median here, 14, we then cross off each end to find our first quartile. We get 2 here, which is 13. Add them together, divide by 2 to get 13. The third quartile, we'd cross off each end here. We would add those 2 18s together, divide by 2 to get our third quartile is 18. So we found the 5 needed values. Once we found those, now we can graph the data. So to do that, we create a number line. Here I started at 8. And they just, let's see here, they went by 8. They went by 2s here. Okay, so 8, 10, 12, 14, 16, 18, so on and so forth. Okay, so we plot our minimum value, which is 11, about right here on the number line. So there's my minimum, that's 11. Then we have our first quartile, our value is 13. So here's 13. Our median is 14, right here. Then we have our third quartile, which is 18, and our maximum value, which is 23. So notice how they have a point at each value we found, and then the whiskers are from your minimum to your first quartile, and from your third quartile to your maximum, and then they put the box around your first quartile, the median, and the third quartile. So this part here is your interquartile range, and here we have our whiskers. So that's why it's called a box and whisker plot. Example 4, they've already given you some box and whisker plots, and they want you to answer questions based on these two situations here. So it says, which data set has a smaller range? So here we're working with years. And so we have year 2000, year 2007, and we're looking at the range. So the range is what's the interquartile range here. So which one has the lower range within the box section of this? So it's going to be year 2000. The data set for 2000, because the distance between the points for the least and greatest values is less than 2000 than for 2007. So you're looking at those graphs there to answer the following questions.